Okay, it says we're recording. All right, so today we're going to do the very last section of the chapter, whoop, whoop, and that is 1311, and it's inverse circular relations as math models. All right, I'll just go into an example, and it's going to be for the Tarzan problem that we did in notes from 13-8 notes. We're going to find the first three positive values of time. We used T in that problem, for which Tarzan is directly over the riverbank. All right, so we're going to go back to 13-8 notes. We want to find the first three positive values of time t for which Tarzan is directly over the riverbank. So let me remind you of what was the 13-8 notes. If you remember, this was the Tarzan problem where he's swinging back and forth on his grapevine, and as he swings, he goes back and forth across the riverbank. Here was the riverbank right here, going alternately over land and water. And then Jane decided to mathematically model his motion and starts her stopwatch. We let y be the number of meters Tarzan is from the riverbank. So from the riverbank was our 0, right? And assume that y varies sinusoidally with t, and that y is positive when Tarzan is over water, which is why we had y was positive 17 over here, and negative when he was over land. So that was the problem, if you remember. So now what we're going to ask is the first three positive values of time t for which Tarzan is directly over the riverbank. So directly over the riverbank, if when he's all the way, he goes to a maximum over here over water of 17 meters. He goes a negative, we did negatives for when he was over land, and it was as far as negative 23 meters over land, but right over the riverbank was actually the distance where y was measured from the riverbank, right? So when we're asking directly over the riverbank, what will your y value be? What was y when it was directly over the riverbank? Here was the riverbank right there, and it was when y was 0. And then also from these notes, if you look back at your notes, we ended up coming up with the equation, and we had, it's the notes from that day, we had y was equal to negative 20 cosine of pi over 3 times t minus 2 minus 3. So I'm going to write that down in just a minute. And then let's look at the picture. Right here was the sinusoidal graph representing Tarzan's motion across the water and the land. And we're now wanting to find the first three positive values from when Tarzan is, no, we're not wanting the first three positive. We want the first three positive values of time, t, yeah, for which Tarzan is directly over the riverbank. So when y is 0 is this t axis. That's when y is 0. So it's positive up and then negative down. And the first three times that y is 0 would be here. Here's the first one. Second one, it's when the graph is crossing the x-axis or t-axis since it's when y is 0, and then also right here. So that was the third. That's going to be the third value we find. This will be the second value we find, and this will be the first value that we find. This was from the notes on 13.4, right? So I'm expecting some value less than between 0 and 1, some other time value 3 point something, and then another time value of 6 point something when I go to find my answers. Okay, so I'm going to write this equation on my paper right now. So from the notes on 13.8, we had that y was equal to negative 20 cosine of pi over 3 is t minus 2 minus 3. And what we're going to do now is we are going to solve for t in terms of y. And we'll do the same process that we've been doing in the last 2 days. And that is you're going to add the 3, right? Add the d part over to this side. So we've got y plus 3. If you remember on the problems that they were given, your d was always in front here. It was like a minus 3 and then minus 20 times. So that's why it's over here on the end this time now. So adding 3. All right, got rid of that one. Next thing we'll do is divide by the negative 20. So we'll do y plus 3 divided by negative 20 is going to equal cosine of pi over 3 times t minus 2. Next thing we did was take the inverse cosine. So inverse cosine of y plus 3 over negative 20 is equal to pi over 3 times t minus 2. And then we need to divide by pi over 3, but it's a fraction, so instead I'm going to multiply by the reciprocal. So I'll multiply by 3 divided by pi. There's not a 2 pi this time, so I don't need to put parentheses around it, around the pi. It's just a single value, so your calculator won't give you an issue. Alright, so I got rid of the pi over 3. And then the last part is the 2. By adding 2 to both sides, I'll have 3 over pi times inverse cosine of y plus 3 over negative 20 plus 2 is equal to t. All right, so that is everything where you just plug values into y, and we're going to be able to solve for t. All right, so we want the first 3 values of t when y is 0. So when y equals 0, now we're going to plug in a t would equal 3 over pi times inverse cosine of 0 plus 3 over negative 20. So that's going to give you a negative 3 over 20. It's 2. And then if you remember from yesterday, you're not going to put the whole thing in your calculator. You're just going to put inverse cosine of negative 3 over 20, because here's the dealio. Your calculator, that's a negative cosine value, so your calculator is going to give you the quadrant 2 answer. Cosine is negative, inverse cosine is a rainbow, so it's going to give you an answer between 0 and pi, right? But it's negative, so it'll be here. Calculator is going to give you this answer there, but we also know that cosine is also negative here, which will be the negative of whatever answer our calculator gives us. All right, so let's put that in our calculator. We need to be in radian mode. Radian mode. It says rad. All right, so I'm just going to put in the inverse cosine of a -3 divided by 20. And it gives me 1.7136. Okay, so that is the quadrant 2 angle in radians when cosine is this guy. So this was 1.721. The 6 says round that 3 up to a 4. Remember, in radians, we're going to go to 4 decimal places. So that was that one guy. And then I'm just going to use -1.7214 to get the quadrant 3 angle that has a cosine of -3/20. Okay, so remember we've got to plug in these values into here and then into there also. Okay, so let's start when t is positive 1.714. That's confusing, huh? How about I cross that part out? When this pink rectangle is 1.714, right? Then t would be 3/pi times 1.7214, and then we're going to add 2 to it. So I've got 3 divided by pi times 1.7214, and then plus 2. All right, so I got one value of that it's about 3.6438. And if you remember, when I looked at that graph, between 3 point something was one of them. Or which one? 3. Okay, so that we just found the second time that Tarzan will cross over the riverbank when y is 0. That was the second time. That's what we just found. What we can do, since we have that in our answer right now, is we can take this and add the period to it, and then we can compare all the values we get to find the first 3 smallest values. So if we add the period, and I didn't remind you what the period was, look back on your notes, right, from 13.8, we had found that the period was 6. Yes, period was 6. So that's what I'm going to add to this value. Add 6, and that'll give you 9.6438. So that's possible one, but I'll box it just so I can find it later. But it may not be, like that might be too big, right? The other way to get the other angles that we're going to get are, we got this -1.72 for this pink box. So when our value there was -1.7214, then our t value would be 3/pi times a -1.72 plus 2. So we'll go 3 divided by pi times -1.7214, and then a plus 2. And I got 0.3562 rounding. 0.3562. Okay. We look back at our picture. 0.23 be that one. We just found the first time that he's positive. And then we'll add the period of 6 to this one, and that'll give you 6.3562. Yeah. So let's look at this one and compare it. These 4 answers that we got. We only need 3, and we want the first 3, so we're going to choose the smallest 3. But let's make sure. We've got the 0.3562 was this first guy. The 3.6438 was the second one we found, and then we're going to choose. So we're going to choose those three as our three answers. We're not going to give the 9, but if you look at our graph, look, there's the 9.64. That's what happened when we added the period to this guy. Brought us over to that one. So adding the period to the first one is what gave us the positive one. And so answers are 0.3562. Or I guess I should write it in words, huh? Okay, so the first three positive values of T when Tarzan is directly over the riverbank are, since there's three, are, the first three positive are when T is 0.3562, 6.3, nope, I skipped over the 3 one. I'll put them in order. 3.6438 and 6.3562. So we don't need to give that fourth one that we had found. And of course, compare the two graph from 13.8 notes, and you see beautiful. Doo-doo-doo. Yay. All right, that's the end of chapter 13. You did it. Yay. All right, I hope you guys are having a fabulous day. And come on. I'm presenting. I want to stop presenting. Maybe. There we go. All right. You guys have a good one. Come see me in office hours if you have questions. Stay healthy, stay safe.